Many thanks. I am privileged to present you my understanding of how gene therapy is really coming very quickly, certainly in my clinics. And I will take you through a few examples. I work as a pediatric neurology in London, and I see children with mostly neuromuscular disorders. Next slide, please. These are my disclosures. As you can expect, I'm involved in a number of clinical trials, also provide some advice to companies. I'm not going to be remunerated for this particular presentation. This is part of my academic talk. Next slide, please. So the first high-level question is, what are genetic diseases? And you may or may not be aware that there are approximately 10,000 rare disorders that affect 6% of the population in Western society. So on one hand, the majority of us doesn't have these rare disorders, but a large number of the population does. 80% at least of these 10,000 rare disorders have a genetic component. They are often disabling and expensive to manage. Most of these conditions are inherited from one of our parents. And 1/3 of the children with rare diseases die before the 5th birthday. This is one area of my work and expertise, next part. And this is, on the right-hand side, an example of how the conditions can be inherited from, in this particular example, from one affected male, in gray, to his offspring, and how this then continues to be transmitted. There are different modes of inheritance, but this is beyond the scope of this presentation. Next slide, please. So we have more than 20,000 genes distributed in the 23 chromosome. On the left-hand side, you see the 23 chromosome. Each of us and every single cell in our body has one copy of the chromosome from our father and one from our mother. And therefore, every cell contains, every chromosome contains thousands of genes, and occasionally some of these genes may have a misspelling, and that is what causes a genetic disease. Next slide, please. Now, how can you correct permanently a genetic disease, and how you can do it? Now, traditionally, in the more distant past, although this is still used, organ transplant was the only way to deal with some genetic disorder, and I will give you one or two examples next. In the last maybe 15 years, cell-based delivery.
Yeah, you're a big shit gobbler.
Somebody muted me, but the cell-based delivery of corrected cells have been also used, and I will provide you some examples. Next part. But I think what is really happening at a faster pace is that the direct delivery of a transgene or genes that have been corrected to patient directly. Next slide, please. So in terms of the organ transplant, this is something probably many of you are aware of. There are a few conditions where if you have a genetic disorder, an example is thalassemia. In thalassemia, the problem is in the ability of your bone marrow to produce normal red cell. In that case, you can do a transplant of the bone marrow and take a donor, give the bone marrow to the children. Cell-based delivery of corrected cell is a relatively more recent modification. You can take, and these are, for example, conditions that have been really completely transformed are immunodeficiency. You may remember several decades ago, the bubble boy syndrome. These are children who cannot be exposed to the environment because of the immune deficiency. And next part, you can take some of the cells from these affected children, from the bone marrow, take them, you culture them in the laboratory, then you take a virus, you infect the cells with this particular virus, that has a corrected genes, next part. And then once you expand these cells in the laboratories, and there are enough, and the gene is inserted where you want, you can put the cells back into the individuals, and that individual will be cured for life. This has been transformative. However, you cannot do this for vast tissues. For example, you cannot do this for muscle, you cannot do this for complex tissues. Next slide. And for some of these, other more complex conditions, for example, if you wanted to correct all cells or many cells in the brain or in your muscles and so on, there are different strategies. This is the direct delivery to the patient of a gene using a vector. This is also a virus, but this time the strategy is different. The first, you take the virus and you strip from inside all the genetic material of that virus. You do this for two reasons. Firstly, because in that way, the virus is even safer because it does what you want, not what the virus would do, next part, but also because you need to make space for the gene you want to reintroduce so that can be used for the patient. Then you use this virus really as an envelope to deliver to the patient the gene you want. And this is often done by intravenous injection. And as we was mentioned earlier on, this is a one in a lifetime injection, or in some condition, directly in the organ of interest. Next part. And these are examples of both approved products on your left-hand side with some cancer, some eye disease, some metabolic disease, and spinal muscular atrophy, where in Europe now there are approved therapies. And on the right-hand side, people like me are involved in multiple clinical trials for a number of neuromuscular condition and metabolic condition. Next part. And I think this is a very recent review in one of the Nature journals regarding how this particular type of gene therapy is really gathering momentum with an increased number of clinical trials that eventually and hopefully will come to approved products to be used in clinics. Next part. And these are just two examples, well, actually, it's one example of one particular family I've been involved with. These videos have been consented to be shared. And you will see on the left-hand side first a girl who has a wheelchair and she's carrying her sister in front. Now, the girl on the left-hand side, she never walked. She's been using the wheelchair. She needs to be ventilated during the night. And you can see the sister that has been treated very early on. She clearly is a very different child. And today, at the age of 3 years, I cannot tell the difference between this child and a normal child. And therefore, that gives you a very tangible example of what gene therapy can do in the real world. Next slide. So I think that this session is also been organized to make you think how the future would look like. I think that there is no question that the number of clinical trials and products under development for gene therapy is expanding. Of course, these are still rare conditions, so it's not that there will be thousands of products coming your way in the coming days. But at the same time, for the first time, some of these gene therapy products really have the possibility to shape the way we do our clinics, the way the healthcare system in European countries needs to be organized. We need training, we need registries to collect the long-term effect of this medicinal product. And of course, clinical services need to think how to reconfigure themselves to deal with how different patients will be in the future. And the next and final slide is firstly to thank the people who work with me in my hospital, at the Women's Street Hospital, but I think really also to thank you because on the right-hand side, you have the European project. I'm at the moment coordinate the BIND European project, but I've been involved in many projects related to rare disorders, and I really thank the European Commission because they work that we and others do on the rare disorder has received a major help from the European Commission. Thank you.